The parabola can be defined by a set of points in the coordinate plane. A parabola is the set of all points xy in the plane that are the same distance from a fixed line called the directrix and a fixed point called the focus not on the directrix. So here we have the focus, here we have the directrix, and here we have a point xy, and the distance from that point xy to the directrix is the same as the distance from that point xy to the focus. If you look at all the points that have that characteristic, it draws out the shape that we call a parabola. Every parabola has an axis of symmetry that passes through the vertex of the parabola, so there's the vertex, and the focus. So the line that goes through the vertex and the focus, that line is called the axis of symmetry. That line is perpendicular to the directrix of the parabola. The vertex is the midpoint between the directrix and the focus. So because that point, the vertex, is on the parabola, its distance to the focus and the directrix have to be the same. The line segment that passes through the focus and is parallel to the directrix, so it would also have to be vertical, is called the latus rectum. And the endpoints of the latus rectum lie on the curve itself. So as you can see, the two endpoints here are actually a part of the parabola. The distance from the vertex of the parabola to its focus, P, so that distance there, is the same as the shortest distance from the vertex to the directrix. So that's that distance there. And the length of the latus rectum is 4 times that distance P. So if that's the latus rectum, the length of that latus rectum is actually the absolute value of 4p. So the equation of the parabola with a vertex hk and an axis of symmetry parallel to the x-axis is y minus k squared is equal to 4p times x minus h. So that's the standard form of a parabola that opens either to the right or to the left. The vertex is that point hk, and you can get those numbers from the equation. And the axis of symmetry would just be the horizontal line, in this case, y equals k. The focus of the parabola would be a point on that axis of symmetry, and it would be p units away from hk, or p units away from the vertex. So since p is that value, if I go p units to the right here, that would be the point called the focus. So the focus has coordinates h plus p comma k for a sideways opening parabola. And then the directrix would be p units in the opposite direction from the vertex. So if I go p units in that direction, I get the directrix. And the equation of the directrix is going to be x equals h minus p. So let's sketch the graph of the quantity y minus 3 squared equals 20 times the quantity x plus 10. Well, first we want to put it in the right form, standard form, or the quantity y minus k squared is equal to 4 times p times the quantity x minus h. So we'll rewrite this to fit that form. The y minus 3 squared is just y minus k squared. 20 is the value of 4p, so if I factor out the 4 out of the 20, the other factor would be a 5. And then instead of x plus 10, I want to write it as x minus h, and x plus 10 can be written as x minus negative 10. So I can identify h, because this is x minus h has to be negative 10. I can identify k, because this is y minus k, so k has to be the value 3. And there I can find the vertex of the parabola. The vertex of the parabola is the point hk, which in this case is negative 10, 3. I'll just plot that point, negative 10, 3, in the coordinate plane. And I see here I factored the 4 out of 20, leaving the value of p to be 5. So p is equal to 5, and the focus of this parabola is 5 units from the vertex along the axis of symmetry, which in this case is horizontal. So I'm going to go 5 units to the right here, 1, 2, 3, 4, 5, and that's where the focus of the parabola would be. If I go 5 units in the other direction, that's where the directrix is going to be. So that line is the directrix, and that's the line x equals negative 15, while the focus is the point negative 5, 3. So there I have the vertex, the focus, and the directrix of the parabola drawn. And now I'm going to look at finding the length of the latus rectum. Well, the latus rectum is 4 times the value of P, or basically that number, 20. So the length of the latus rectum is 20, and the midpoint of the latus rectum is the focus of the parabola. So that means from the focus, I need to go 10 units above and 10 units below, and I'll find the endpoints of the latus rectum. So this line segment is the latus rectum. The significance of that is I know that the parabola has to go through its vertex, and it also has to go through both of the endpoints of the latus rectum, and this is then what the parabola should look like. So that is how we draw a parabola given this form of the parabola's equation. Let's look at another example. So in this case, we have sketched the graph of the quantity y minus 4 squared is equal to negative 12 times the quantity x minus 6. So we're going to put it in the correct form here. So when I factor the 4 out of the negative 12, I get 4 times negative 3, and this is the correct form of y minus k squared is equal to 4 times p times x minus h. So here I can identify that h is 6, so h is 6. I can identify that k is 4, and now I know that the vertex of the parabola is the point 6, 4. So the vertex is the point 6, 4. From that vertex, if I identify the value of p, which in this case I see p is negative 3, I can find the focus and the directrix. If I go p units along the axis of symmetry, I will find the focus. So from this point, I have to go negative 3 units along the axis of symmetry, and that's where I'll find the focus. So the focus is the point 3, 4. If I go 3 units in the other direction, 1, 2, 3, I will find a point that's on the directrix. So the directrix in this case is the line x equals 9. So there's the directrix. And now for the latus rectum, the length of the latus rectum is the absolute value of 4 times p, or the absolute value of negative 12, positive 12. So from the focus, if I want to draw the latus rectum, I have to go 6 units above it and 6 units below it. So that is the latus rectum with a length of 12. And once again, the significance there is to draw the parabola. I know the parabola has to go through both of those endpoints of the latus rectum. So this would be the graph of my parabola. All right, so what about if the parabola opens vertically, opens either up or down? Well, the equation of a parabola with a vertex of hk and an axis of symmetry that's parallel to the y-axis is x minus h squared is equal to 4p times y minus k. That means we know then that the vertex of the parabola is going to be the point hk, so that point there is the point hk, and the focus of the parabola is going to be p units away from the vertex, but on the axis of symmetry. So that's going to be the point h comma k plus p, and the directrix is going to be p units in the other direction. So if I go p units in the opposite direction, that'll be the line y equals k minus p. So let's go ahead and look at an example. So sketch the graph of the quantity x minus 3 squared is equal to 20 times y plus 9. So first I'll put it in the standard form, x minus h squared is equal to 4p times y minus k. So x minus 3 squared is equal to, well, I'm going to factor the 4 out of the 20. That's going to be 4 times 5. And then it's going to be y minus negative 9 for the y plus 9. So I can identify the value of h to be 3, because that's x minus h. The value of k to be negative 9, because that's y minus k, and then that tells me that the vertex is the point 3, negative 9, and we'll plot that point 3, negative 9. From there, I can identify the value of p, because this is 4 times p is 5, and if I go 5 units along the axis of symmetry, which is vertical in this case, that's 5 units up, I find the focus, And if I go 5 units in the other direction from the vertex, I will find a point that is on the directrix. So 5 units below the vertex. So the focus is the point 3, -4, which is h comma k plus p. And the directrix is the line y equals k minus p, which in this case is y equals -14, that horizontal line. The length of the latus rectum is 4 times p, which in this case is 20. So starting at the focus, if I want the latus rectum to be 20 units long, I go 10 units to the right and 10 units to the left, and that is the latus rectum. Once again, the parabola has to go through its vertex and both of the endpoints of its latus rectum, so we get this parabola here. And that's how we graph parabolas in standard form.